Okay, so yesterday we talked about two types of sequences. Now there's lots of different types of sequences, but yesterday we talked about two types of sequences. We talked about arithmetic and geometric. So arithmetic is where you have the common difference that comes from adding the same thing every time. Geometric is where we have the common ratio that comes from multiplying by the same thing every time. Now, our two formulas that we talked about that were most helpful were the explicit ones. All right, explicit for geometric is G sub n equals G sub 1 times R to the n minus 1. That's if you're multiplying. It gives you an exponential. Repeated multiplication is written as an exponent, so that's why it looks like exponential. Arithmetic is when we're adding the same thing every time. So it looks like this: the first term plus the common difference times n minus 1. Or your teacher might write n minus 1 times d. I'm writing both of them so that you see both, depending on who you might have as a teacher. Okay, so those were our two formulas we talked about yesterday. Now, on the first six, I want you to just look at them and try to decide, are we multiplying by the same number every time? Are we adding by the same number every time? Because if you're multiplying, it's geometric, put a G. If you're adding, it's arithmetic, put an A. But if you can't find a pattern where you're adding or multiplying, then it's neither. So put an N. All right, so take a moment, look at 1 through 6. A for arithmetic, G for geometric, N for neither. All right, so sometimes it may appear that there's not anything. Like number 1 looks kind of weird. I know I'm not multiplying by the same thing because it goes from positive to negative and then stays negative. So I know I can rule out geometric because if it had a negative ratio, it would go positive, negative, positive, negative. I can totally rule out geometric. So all I have to test for is arithmetic. Now, if you can't see, you can always take a term and subtract the one before it. And when we do that, I get negative 35. If I take a term and subtract the one before it, what happens to minus and negative? It turns positive, doesn't it? And I get negative 35. If I take a term and I subtract the one before it, yeah, that wasn't English. I don't know, it is. Can't explain that one. All right, I get negative 35. So sometimes we can't look at it and see it. But if we do what a common difference says, take any term and subtract the one before it, do you see that we have a common difference? Yes, this one's arithmetic. And the Moby is excited about that. This one's arithmetic, and the common difference is that crazy negative 35. Questions about number 1? All right, this is, I can tell, down by 14. This is down by 14. This is down by 14. Which one is it? Arithmetic, geometric, or neither? Arithmetic, and my common difference is negative 14. Oh, I can tell that one is not arithmetic because it's changing by big different amounts. So I'm going to test geometric, which says I can take any term and divide by the one before it. Well, I don't know what that is, so I'm punching it in. 213 divided by 31. Well, that's ugly. 6.871-ish. Now let's take 4, 4, 5, 9 and divide by 2, 13. 4, 4, 5, 9 divided by 2, 13. Something very different.
So it means it's neither.
So this is a neither. I am neither adding by the same amount or multiplying by the same amount. Now, you may have been able to look at that and tell. You may not have. You may have been, oh, this is 20 times bigger and that's only about 6 times bigger. That's fair. If you can do that, don't show the work. All right. Goodness. Now, these are fractions. We don't like fractions, but we got a calculator, so that's all right. Looks like to me it's multiplying by 4. Did y'all see that? Okay, so if I took any term and divide it by the one before it, this is what you'd have to do on your calculator. Any term and divide by the one before it. So 3 divided by 7, and then divide by 3 divided by 28. I get 4. And if I did 12 sevenths divided by 3 sevenths, I get 4. This one is geometric, and it has a crazy ratio of, well, the ratio is not crazy. The ratio is pretty simple, 4. The fractions are ugly. All right, this looks like times by 8, times by 8. But is this one times by 8? This is not multiplying by 8. So, it is a big neither. Two of them were the same, but one of them was different. If any of them are different, neither. Well, this is minus 3, plus 3, plus 3. Neither. Because it has to be the same. Those two were the same, but these two were different. All right. Questions about what to look for? Okay, now this says write the explicit formula for the arithmetic sequence. Okay, explicit for arithmetic. A sub n equals a sub 1 plus d times n minus 1, or n minus 1 times d. You can write it either way. Both correct. So we got to talk about what each little part means again. This is our first term. This is that common difference, what we're adding by every time. So in this one, a sub n equals, what is the first term in that sequence? Negative 25 plus, okay, and it's not just 4, but it is negative 4 times n minus 1, because it's down by 4, down by 4.
So I just put negative 25 minus 4.
Yeah. If you wrote negative 25 minus 4 n minus 1, beautiful. Yes. Okay, you try. Number 8. You can, but you don't have to. I would just leave it. So if you have 33 plus -5 times n minus 1, I'd just leave it just like that. Or you could write -5. Because this is in the explicit formula form. Alright, so those are our adding ones. Now let's look at some geometry. This is where we're multiplying. Okay, so slide this down. Grab the geometric. Alright, so first of all, we have to figure out what our common ratio is. Do you see we're multiplying not just by 2, but by -2. The common ratio is -2 because it's switching signs. Whenever it switches signs, your common ratio is negative. So when we use this formula, g sub n equals g sub 1 times r raised to the n minus 1. Our r goes inside of here in parentheses, -2. Now what is your first term? 4. And we're done. All right, now this one, you may not be able to look at it and tell. So to find that r is equal to, you can pick any term and divide by the term before it. Any term and divide by the term before it. So whether we do 104 divided by 832 or 13 divided by 104, either way we get 0.125. Now your teacher may hit the math fraction enter button. Math fraction enter. What is the fraction for 0.125? 1/8. So you might see it written as 0.125, you might see it written as 1/8. So g sub n equals the first term, 1/8 or 0.125, either way, to the n minus 1. Now, recursive formulas for geometric and arithmetic, I'm not as fond of because they're not as helpful, but we can list the first couple of terms. So a recursive formula always gives you the first term. The first term is this. So instead of using A or G, they use T for the first term. Now, do you see what this says? To get to the next term, you subtract 3. So what is 8 minus 3? 5 minus 3 minus 3. That's how you do it.
So we just write the patterns.
Yes, you just write the pattern. That's all sequences really are. Just that arithmetic and geometric are special patterns. Okay, the second one starts with 256. But what does it tell us to do here to get to the next term? Multiply by a fourth, which is the same as dividing by 4. You can do it either way. So if we took 256 and we divided by 4, we get 64. Divide by 4, 16. Divide by 4, 4. So multiplying by a fourth is equivalent to dividing by 4. So that's what we chose to do. All right. Now, is the next one arithmetic or geometric? Are we? This is geometric. So you try number 13. You got it. Okay, the next one says find the 12th term of an arithmetic. So arithmetic is this formula. N minus 1 times D, or D times N minus 1, either way. Whose first term is 5. So where does 5 go in the formula? A1, A sub 1. And the common difference is 11, so where does the 11 go? D. And it asks us to find the 12th term. So where does 12 go? N. So the 12th term is, that's what this means, A sub 12. The 12th term is 11 times 11 is 121, plus 5 is 126. Now, you're welcome to punch that in on your calculator. All right, so you try number 15. Oh, rock and roll into that. You want to leave it in here and charge it?
Sure.
I got a charger up there on my desk. Well, we're going to do a little more. The quiz will be more like this. It's all right. I think after your teacher goes over it today, if you understand what I'm doing, you're going to be fine.
Okay.
Let's see. I keep it right here. And then that way I can charge them. And I will let you use that. Yeah, and you can swing back by. All right, so this one we want the 8th term, so A sub 8 is equal to the first term plus 8 minus 1 times negative 3. Okay, so 9 minus 21 is negative 12. Did you get negative 12?
Yes.
Yay!
She doesn't know what anything on Twitter is. Or anything goes or anything goes to fix things.
This is so bad.
You don't have to watch this.
What's wrong?
Okay, now I'm looking at it differently.
Okay, then.
I was just looking at number 17 differently.
Oh, yeah.
I thought those were grades, but those were scores.
Alright. So, number 16. This one isn't arithmetic, it's geometric. So we have to use this formula. G sub n equals G sub 1 r to the n minus 1. So it tells us to find the fifth term if the first term is 4 and the common ratio is 3. So we plug in 4 for the first term, 3 for the common ratio, 5 for n, because we're trying to find the fifth term. So we get 4 times 3 to the 4th. And you should get 324. Now, I'm going to back up to the previous page. Okay, and I'm going to change this problem a little bit. I'm going to say if negative 42 is the last term in the sequence, what is the position they could say position or number of the term, either way. Okay, so what we're looking for is n. This time, that's what we're looking for. Where does negative 42 lie in this sequence? So, we know the last term is negative 42. We know the first term was 9. And we know the common difference is negative 3. What we have to solve for now. Okay? So, on this kind, we can just do regular equation solving. On geometric, though, we're going to have to use logs. Okay? So this one, I would subtract 9 and get negative 51 equals n minus 1 times negative 3.
This is what I messed up on the paper. That's very good.
Yeah. And then we divide by negative 3.
It was like what I did was like I moved the number that you add, but when you multiply it to like n minus 1,
Mm-hmm.
I distributed.
Oh, you can do it that way.
I
And you
was just
should
confused
still
when I
get it
did it.
right. It's just a little harder. And then we add 1. So what that means is negative 42 is the 18th term in the sequence. So if we wrote out a list, it would be the 18th number we would get to.
So we have like 18 total.
Mm-hmm. Yeah, there'd be 18 total terms. And that would be the last one. Yes, ma'am. Now we're going to go back and do one with geometric. So I'm just going to add a little second. What is that? That is not what I thought I was doing. Add a little second part to this one. I'm just going to cover up some of this stuff. Okay, so this time we're going to say 8,784 is which term in this geometric sequence? So this time it's geometric. So we would have 8,748. That's not what I said though, was it? All right. Equals 4 times 3 to the n minus 1. And this problem right here is why we do this in the log unit. This is the only reason why this comes in the log unit. So to solve this, you would have to divide by 4 first. And we get 2,178 equals 3 to the n minus 1. And we want to solve for an exponent. So we have to take a log. What happens to this exponent when we take a log? It comes out in front. So we have log of 2,178 equals n minus 1 times log of 3. You divide by log of 3. And you get 6.
I got 7.
I think 6.9, so 7.
Okay. What did I do? Oh, I keep flipping my numbers, guys. This is 87, not 78. I'm sorry.
Welcome to my life.
Okay, that makes a difference. Because it should be, your check step right here, guys, is they should all be perfect. Okay, so if we did the actual correct numbers instead of where I flip-flopped them, it gives you an exact 7. So it is the 8th term, because when we add 1 to both sides, we get 8. Okay, so those are the types of problems you're going to see today. Now, you're going to see a couple word problems, but most of them are like the ones we've already done. We're not going to do all the word problems on your page, but we are going to look at a couple of them. Which one looks most interesting to you?
The last one.
The last one? Let's do the last one then. All right, so number 20, we're going to start from the bottom up. Each year, a volunteer organization expects to add 5 more people to the number of shut-ins whom the group provides home maintenance services for. Okay, first of all, you got to understand what this means. Do you know what, if we call someone a shut-in, what that means?
So
That basically means they're not able to leave their house by themselves. So that happens sometimes with older people. You know, when they lose their license, if they're no longer capable of driving, or if they have severe health issues and they can't leave their own home, they're considered a shut-in. That's what that means.
would that include like someone in a wheelchair?
It could, But generally they can still get out and about, but if they have other health issues that keep them at home, like towards the end of my grandfather's life, he was a shut-in. He was not able to drive himself anymore. He was not able to get out of the bed by himself anymore. So people, his community, helped care for him. So this organization is helping those people, but here's the important part for the math problem. Actually, the important part in life is the other part, but the important part for math is that we're adding 5 more people every year. So currently they provide services for 32 people. How many people would they expect to serve in 20 years later? So currently, right now, we have 32 people. But if we're adding 5 every year, so that's our first year. So if we add 5, the next year we would expect to have 37, then 42, and so on. Right? So this is arithmetic because we're adding. So for the 20th year, it would be the number of people in the first year, 32, plus 20 minus 1 times 5. So that would be 32 plus 95 means 20 years later, they expect to serve 127 shut-ins. That would be a huge service outreach program right there. When my dad retired, that's what he did. He would go and cut the grass for the people that couldn't cut it anymore. And he would fix things around their house and paint things for them, repair plumbing, stuff for the people in his little, it was a tiny little community, so everybody knew everybody. So. All right, let's take a look. Which one do you want to try next?
19.
19. We're working our way back up. All right, so a bookshelf has 7 shelves of different widths. Weird. Each shelf is narrower than the shelf before it. So it's kind of like one of those like that. All right. The bottom 3 shelves are 36, 31, and 26 inches. So they are decreasing by the same amount. Does that make you think arithmetic or geometric? Arithmetic. So my first one is 36. My next one is 31. My next one is 26. Okay. What would the next one be? 21. What would the next one be? 16. And what would the next one be? 11. That's 1, 2, 3, 4, 5, 6. How many did it say we had? 7. So the last one would be 6. We didn't even need a formula, did we? Now, the second question, I can't answer. Because I know how wide they are. But it didn't tell me how long they are, did it? So I can't find space. Space is area. So we can't find area with one dimension. And that's all we have here. So we'll go row. I left out a number. I'd have to tell you each shelf is, 24 inches long or something like that for you to be able to find the area. We could answer the question, how many linear feet of shelving would we need to create this bookcase? But, all right. Which one now? I think we're going to have time for all of them.
16. Or 18. 18.
All right, 18. Going back up. Aw, Hannah's making Easter baskets. She has 13 baskets left over from last year. She plans to bake 12 more each day. If there are 15 work days until the day she begins to sell the baskets, how many baskets will she have to sell?
This is to you.
Okay. Now, are we multiplying how much we do every day, or are we consistently adding the same amount? Consistently adding. It's arithmetic again.
So all of them are.
All right, so now that we know it's arithmetic, I want you to try. Okay, if you're not sure what to do, you ask. Okay, so on this one. We have 13 baskets left over. That's our ace of one. That's our starting amount. So 13 goes here. She plans to make 12 more each day. That is our common difference, 12. We have 15 work days. 15 is our end. So how much will we have after 15 days?
181.
Okay, so we're going to do 13 plus 14 times 12. And you are correct. After 15 days, we will have created 181 Hannah wheel baskets. All right, now I want you to try number 17 on your own. It's our last one, and we'll go over it in a second.
If I read it in pen and get it wrong, I'm pretty upset.
Well, you read it and tell me, do you think it's arithmetic or geometric?
I'm just gonna guess G.
Hmm?
We got 107.
Yes.
Wait, that's right?
Yes.
There
Good.
was extra credit.
No.
There was extra credit.
I love it when that
Woo!
happens.
All right.
Wait, where's an extra credit?
Well, he got extra credit.
He probably took in his review guide.
Okay,
checked with
so
No.
this is arithmetic. His first term is 50, and his common difference was 3. If he takes 20 tests, what should he be up to? So, ace of 20 equals 50 plus 20 minus 1 times 3. So that's 50 plus 67. Edgar is flying high with extra credit and 107 on the 20th test.
Because he turned in his review guide checked with red ink.
It was checked with red ink. I like it.
Not metallic gold.